Okay, so we're going to start this first lesson with a review and a preview of relations and functions. So in terms of relations, much of mathematics involves the search for patterns and relationships between sets of data. Many real-life applications of mathematics investigate the relationship between two different quantities. For example, the cost, represented by C in cents per kilometer, of driving a car is related to the speed in kilometers per hour at which the car is driven. Or, the price, represented by P in dollars, of a watermelon is related to its weight in W kilograms. In mathematics, a comparison between two sets of elements is called a relation. In previous courses, like Math 10C, we represented the relation between two quantities in ways including a word relation, an equation, a table of values, a graph, a set of ordered pairs, or in function notation where it's actually a function. These representations will be reviewed in this lesson. So if we consider the following relationships between x and y. The relationship defined by the equation y is equal to 3x plus 5, or the relation defined by the equation y is equal to x squared plus 4. In what ways are these two alike, and in what ways are they different? Well, first, if we're looking at how they're alike, we can say that both are written in the form y equals. In what way are they different? Equation 1 has a degree of 1. So it's linear. Equation 2 has a degree of 2. So it's nonlinear. If I'm going to use the equations to complete the table of values, I'm just going to replace the x values to solve for what the y values would be. So if x was negative 3, then y would equal 3 times negative 3 plus 5, or negative 4. If I replace x with negative 1, 3 times negative 1 plus 5 is going to give me 2. 3 times 1 plus 5 is going to give me 8. 3 times 3 plus 5 is going to give me 14. And 3 times 5 plus 5 is going to give me 20. For the second equation, if I said that y is equal to x squared plus 4, I'm going to replace x with, in the first one, negative 4. So I would say that y is equal to, bracket, negative 4 squared plus 4. Don't forget, when you're plugging this in, if I'm replacing a variable, to always use brackets so that it actually solves it properly. So if I said negative 4 squared plus 4, that would give me 20. Negative 2 squared plus 4 is going to give me 8. 0 squared plus 4 is going to give me 4. 2 squared plus 4 is going to give me 8. 3 squared plus 4 is going to give me 13. And 4 squared plus 4 is going to give me 20. If I'm using the table of values to graph out what these points are, then I'm going to actually graph out the points from the last set and say that I start with negative 3 for x, negative 4 for y, and I start down here. Then negative 1 and 2. Then 1 and 8. 3 and 14. and 5 and 20. For the second one, I started with the point of -4 and 20, then went to -2 and 8, 0 and 4, 2 and 8, 3 and 13, and 4 and 20. When I'm connecting these points, I can see that the first one creates a straight line, and the second one creates this curved line. In what ways are the graphs the same, and in what ways are they different? Well, let's start with the same. They're the same because they can both be drawn as a single continuous line. How are they different? One is a straight line, and one is curved. The domain of a relation is a set of every possible value which can be used for the input or x value. So any value that I would be allowed to use for x or that shows up for x on the graph is going to be part of the domain. So if I'm stating the domain for y is equal to 3x plus 5, I can see that it covers every point along this graph, and then it would keep going to the left, and it would keep going to the right, which means as far as I can see, there is no limitations on what x can be. So I would say in this case that the domain represented by x is every real number. Make sure that we're using those set brackets. For the second one, it covers all the points on the graph, and it keeps moving to the left, it keeps moving to the right. The domain is the same. There is no limitations. If we're looking at the range, well, for the first one, y keeps moving down, y keeps moving up, which means that the range of this is going to be y, where y can be any real number. In the second case, y starts up high and then comes down, it hits this lowest point, and then it shoots back upwards again, which means that for this one, y has to be either bigger than or equal to the lowest point that it hits, 4, where y is an element of all real numbers. A function relation, or just function, is a special type of relation in which every element of the domain is related to exactly one element in the range. Or if I put in any x value, for any x value, there's only one possible y value. In this case, are these functions? Yes. What visual test can I use to test this? We call it the vertical line test. The vertical line test says that if I took a ruler or just drew an infinite number of lines, vertical lines going all the way through here, there would never be any 2 points on the graph that stack vertically on top of each other. It doesn't matter if, like in the second one, there are 2 points that are side by side, only if they stack on top of each other vertically.